So you might all be familiar with some of the syntax you'll find in a C program, such as these squiggly braces, semicolons. I mean, some other languages have adopted these, such as Java. The syntax is very similar to Java, actually. But C works in a way that it uses tokens. So if you're familiar with languages such as Python, where it really uses white spacing, indentation, and all of these things to sort of determine the program's structure or flow, C is syntax based. So this means that I can, for instance, have white space. I mean, I can write one line of code, then actually back indent and write the next line of code, and C still knows how to run it because essentially all white space is stripped out of the program and it's compiled that way, right? So we need to know about these tokens, really, or like what is a valid token, and this is how we can then determine or write correct syntax, right? So styling, when I mean by styling, sort of like how you write neat and presentable code, is something different to the actual syntax. So, you're doing correct indentation, leaving spaces between sort of functional blocks. These are all things that make really beautiful, like visually appealing and easy to write code. But the syntax itself is a hard or a solid construct of the C language that if you don't follow it, you will get code that either doesn't work or gives you compile errors, which does something you don't want it to do, right? So we have these tokens, and this is what our program is structured from. So we have essentially a few different types. The most common one that you'll see are sort of the keywords. And so these are C programming language semantics used to perform some certain inbuilt function of the C language. So example, the return keyword, as we saw in our Hello World example. So this return keyword here, as we saw in our Hello World example, returns a value from the function. So the word return is a inbuilt keyword of C. You can't use these, like you couldn't call a variable return because they're not allowed to be used. And they do certain functionalities. So I think I have a list of keywords here. And so this is all of the keywords that you can find in C. Now I'm not going to explain what they all mean. We'll come across a fair few of them as we go through this lecture. But as you can imagine, some of them, for instance, are like variable types. So here we have this is a data type. We have another data type, returning from your functions, or you have for instance, your logic operators, which we'll get into. If, switch, else, enum, which you're using for creating enumeration data types. So these are the words that you are explicitly reserved for C's programming functionality if you want, right? And so then we have identifiers. And so this is also one thing that we'll get into a bit later in the sort of the lecture series, is that identifiers in C are just some sort of human readable token, really, that represents some memory location. Because C is such a low-level language in general that everything you write, every variable, you can get its memory location, which we'll definitely get into all of this in a lot more depth. But all you need to know an identifier is a really good way of abstracting it, and sort of if you get this abstraction in your head to begin with, that an identifier is not really so much a variable like in Python, where it's manipulative, you can do all sorts of things to it. An identifier is really just in Python, it's more so that the variable has properties and you can get its string value and all of this. So it's an object, right? But in C, identifiers are just a name that references some memory location. So your variables, your functions are stored somewhere in memory. Your variables are also stored somewhere in memory, right? And so we have these identifiers that when we're writing our code, help us to know which memory location we're talking about, right? Because we don't handle the memory locations directly on like a binary level, but we need to know how to identify, yes, this is my variable A and this is my variable B. So we should all be familiar with this. Then we get into constants, and we'll talk a little bit later in the lectures about the const keyword, but essentially a constant is some value that can't be changed. And when we're dealing with, for instance, embedded systems, we have read-only memory that can't be actually modified during runtime, and a const variable would probably land in read-only memory. So you can't actually ever modify its value throughout the program's execution. And so if we go really into depth of like the compilation, the more especially the linking process, this would land in your read-only memory data segment, right? Strings are then a type of, or I mean, they're a string. So we'll see when we get into the string section, they're actually an array of characters, but they are a type of syntax, meaning that we can have these quotes with some sort of collection of characters between them, and this is referenced to as a string. And so the compilers for C compilers use these strings syntax to do certain things. You know, they'll automate memory allocation, or they'll allocate, for instance, they'll add the termination character, which we'll see later on when we talk about strings in depth. But in this example here, we have, for instance, a constant and a string. So this, because it's defined with these little things, this is actually, this would be, for instance, some like char, some array called A, and this would be a constant string. Then we have our special symbols. So these are used essentially to implement desired functionality, and for a good example of them is these squiggly brackets. And so the squiggly brackets in C are used to sort of contain a block of code, some sort of logical link, a function, a loop, a conditional expression, anything you will, like some logical chunk of code, right? And then we have the operators. And so these operators, which I'm sure you're all quite familiar with from other programming languages or just basic like maths, right? You have like plus, minus. Here is the equality operator. You know, is this essentially is A equals to B. This is some logical expression. If they're equal, this would return 1 or true. I mean, C doesn't have true, but it would return 1. If they're not equal, then it will return 0. And then also the syntax, very important, is comments. So you need to have like the double slash or the double slash blah blah blah, or the asterisk slash block comment style, right? So we'll look at an example of like my Hello World program and break it down into all the different sort of tokens that we have. So if we look at, for instance, the keywords, so our keywords being return, and then what else do we have? Int is another one we'll use in this example. So if we look at our code, we have the keyword here. So this is defining a data type for the function. What it's doing is it's defining that this main function returns an integer value, and the return keyword is saying, yep, I'm going to return 0 as an integer. So we have then, for instance, special symbols. And so if we look at here, so these are to implement desired functionality. And so what this does mean, or what this means in this case, we have a special symbol here. So this marks the beginning of this block code. So it's saying, I want this code from here to be the functionality of the main function, right? And so that's what it's doing by this desired functionality. In this case, it's encapsulating these 2 lines of code inside this main function, right? Similarly, the semicolon here is terminating this return statement, saying this is the end of my return statement, saying I want you to make sure this function's return functionality is only to return 0. If I didn't put this here, the compiler would keep reading and would probably maybe add the next line to the return statement, and then all of a sudden your logic isn't valid. And you have to watch out for the semicolon, because white space is ignored essentially in C for the most part. You know, if I was to leave 2 separate lines and then have some other line, it would probably get put on the back of the 0, and maybe it might actually make sense, and you have some sort of weird return statement, right? Identifiers here. So both of these are function names. Here, the identifier we're writing is actually defining a function. So we're defining our main function, whereas here the identifier is calling a function somewhere else on our system. In this case, it's in this stdio header is where the declaration is. And then we have a constant string. So this is a good example. When I compile this program, it knows that this printf in main is always going to return this same string, is always going to print the same string, and so the compiler will store hello world as a constant string in our read-only memory segment, and will get passed into printf every time this program runs, or every time main is run, right? Keywords. So now we'll get into the C data types.